I'll see some problems on periodic and aperiodic signals. As a first problem, show that the signal x of t equal to e power j omega naught t is periodic with the period two pi by omega naught. We'll see the solution. This x of t equal to e power j omega naught t is called complex exponential signal. So given x of t equal to e power j omega naught t. What is our periodicity condition? X of t must be equal to x of t plus t. So simply we'll write this given x of t in terms of the periodicity condition. E power j omega naught t equal to e power j omega naught of t plus t. So what you're going to get? You're going to get this and this gets cancelled. You're going to get e power j omega naught t is equal to 1. When it will be valid? It will be valid only when omega naught t is equal to 2 pi n. N equal to 1, 2, etc. Suppose if we keep n equal to 1, let's see whether it happens or not. If n equal to 1, what is omega naught t? Omega naught t equal to 2 pi. So, e power j 2 pi, that is equal to cos 2 pi plus j sin 2 pi. What is the value? This is 0, so the value is 1. Okay, so it satisfies. When n equal to 1, it will be 1. So we can say when omega naught t is multiples of 2 pi, then the exponential, the given a complex exponential signal is periodic. From this, what is t? T is equal to 2 pi n by omega naught. When n is equal to 1, we already proved that e power j omega naught t equal to 1. This is from the periodicity condition. So as if n equal to 1, the given signal is periodic. Even if n is 2, 3, 4 also, the given signal is periodic. Okay. What is the minimum period? The minimum period is, you will get minimum period when n equal to 1 implies your t equal to 2 pi by omega naught. So at regular intervals of t, your given complex exponential is said to be periodic. Then the next problem. Show that x of n is equal to e power j omega naught n is periodic only if 2 pi by omega naught is a rational number. Very important problem. Okay. What is the given sequence? The given sequence, why I am saying it is sequence? Because the index here is n. N is for discrete, to represent the discrete signal. So what is the given sequence? X of n equal to e power j omega naught n. Like this, it is also called complex exponential sequence. Okay. So here, we have to prove that this is periodic only when 2 pi by omega naught is a rational number. Then here also you take the periodicity condition x of n equal to x of n plus n. implies e power j omega naught n equal to e power j omega naught of n plus n. So these two gets cancelled. It will be with e power j omega naught n is equal to 1. Will be satisfied. It will be satisfied when omega naught n equal to 2m pi. Omega naught n is equal to 2m pi. Where now m is 1, 2, etc. So what is omega naught by 2 pi now? Omega naught by 2 pi, it is m by n. Omega naught by 2 pi is m by n. In the given question, it is 2 pi by omega naught, it is n by m. It must be rational. Then only the signal is said to be periodic. So if you keep m equal to 1 here, so what it will be? Omega naught n equal to 2 pi. Again, if you keep e power j 2 pi, it will be 1. So for m equal to 1, it is satisfied. Same way, when 2 pi by omega naught is equal to n by m, a rational number, then only the given signal is periodic. Next problem. Find the period of x of t equal to sine 50 pi t. Compare x of t equal to sine 50 pi t with the general expression x of t equal to sine omega t. Okay, so if you compare, what is omega? Omega is 50 pi. 2 pi f is equal to 50 pi implies, what is f? F is equal to 25 Hz. Therefore, the period t, which is equal to 1 by f is 1 by 25, is nothing but 0.04 seconds. Next problem. For the given signals, find whether periodic or not. If periodic, find the period. Under this, the first problem is x of t equal to cos square 2 pi t. Take it as the first problem. Then you can write it as 1 plus cos square theta is 1 plus cos 2 theta. So 2 of 2 pi t by 2. So 1 by 2 plus 1 by 2 cos 4 pi t. You know, as this is not consisting of any frequency, you can call it as DC term. It won't decide the periodicity. This is called AC term. This is the general form. We know the cos signal is a periodic signal. Okay, then how to find the frequency? So now if you observe and compare it with the general expression cos omega t. So if you compare these two, you will get omega is equal to 4 pi. So 2 pi f is equal to 4 pi. So f is equal to 2. F is equal to 2 implies t equal to 1 by 2, that is nothing but 0.5 seconds. Then the next problem. So under fourth one, it is the second type. Under the fourth problem, it is the second one. X of n is equal to cos 2n. Just compare it with the general expression x of n equal to cos omega naught n. You will get omega naught equal to 2. Next problem. And for discrete signals, now do omega naught by period of, what is this? 2 by 2 pi. X of t equals to nothing but 1 by pi. 50 pi t is not a rational number. Compare, already we have seen when it will be equal to sine 50 periodic pi t in the previous problem with the general expression x of t equal to sine omega t. It is not periodic. Okay. So if you compare, what is omega? Omega is 50 pi. Okay. So what is the condition for periodicity of a discrete signal? 2 by f is equal while to doing the problem, what you have to consider? You have to consider this omega naught by 2 pi must be a rational number. Then only you can say the given discrete sequence is a periodic sequence. But it is not a rational number. Hence, therefore, it is said to be the period t aperiodic, or it is not periodic. Now take x of n is equal to cos 2 pi n. Now compare again it with x of n equal to cos omega naught n. So what is omega naught? Omega naught is 2 pi. Now again take omega naught by 2 pi. It will be 2 pi by 2 pi. What is this? 1. We know 1 is a rational number. Implies it is periodic. What is the period? The period is, actually you have to write as 1 by 1. The denominator becomes the period. Period is 1 sample because it is a discrete sequence. Then the next problem. X of t equal to sine 10 pi t plus cos 2 pi t. If you observe the problem, it consists of two terms. Up to now I explained only with one term. Okay, here I am taking the example of two terms. So how to find whether the signal is periodic and how to find the period if it is periodic. Okay, just take two terms, sine 10 pi t, compare it with our normal expression omega t. So implies omega is equal to 10 pi. Therefore 2 pi by t, because it's the first term, take it as 2 pi by t1 is equal to 10 pi, implies what is t1? t1 is equal to 2 pi by 10 pi, that is 1 by 5. Then take the second term, cos 2 pi t, again compare it with cos omega t. What will get? I will get omega equal to 2 pi. It's nothing but 2 pi by t2, because second term take t2, 2 pi. So what is t2? t2 is 1. Now after getting T1 and T2, just take the ratio T1 by T2 by 5 by 1. So we'll get 1 by 5. What is this? This is a rational number. T1 by T2 is a rational number. Therefore, the given signal is said to be periodic. Therefore, the given signal is said to be periodic. Please remember the process. From the first term, calculate T1. From the second term, calculate T2. Simply you do T1 by T2. If it is a rational number, this signal is said to be periodic. Fine. Then how to find the period? Then to find the period, simply period T equal to LCM of T1 comma T2. That is LCM of, what is T1? 1 by 5, and what is T2? 1. So the answer is, what is the LCM of these two? 1. 1 second. It's okay. So T is 1 second. This is the way of doing periodicity and finding the period in the case of two terms. Take another problem. X of t equal to 3 sine 200 pi t plus 4 cos 100 t. Okay? Now, so take the first term. So compare it with the sine omega t. So you'll get 2 pi by t1 as 200 pi, implies your t1 is 2 pi by 200 pi. How much it is? 1 by 100. Same way, compare it with cos omega t. Then you'll get 2 pi by t2 as 100. So implies t2 is 2 pi by 100. What is this? Pi by 50. After finding t1 and t2, what I told? Take the ratio. t1 1 by 100 by t2 pi by 50. So 1 by 100 into 50 by pi. Okay, answer is 1 by 2 pi. Is it rational? No, it is not rational. Therefore, the signal is not periodic. Another discrete sequence problem. Take x of n sine 2 pi n by 3 plus cos 2 pi n by 3. Take the term sine 2 pi n by 3. So now compare it with sine omega naught n. Then omega naught becomes 2 pi by 3. Okay. So what is omega naught by 2 pi? It is 1 by 3. Take it as m by n1. For single term I explained already. And same for second term. Omega naught is 2 pi by 3. So implies omega naught by 2 pi is 1 by 3, which is m by n2. Okay. Before seeing the complete two terms, for the first term if you see, omega naught by 2 pi is 1 by 3. So it's a rational number. So the first term is said to be periodic. First term is said to be periodic. And what is the period? N1 is the period and it is your 3 samples. Here also 1 by 3 is rational. So again it is also said to be periodic. Second term is also said to be periodic. And what is the period? N2 is the period and is again 3. Then now for the combination, take the ratio again. N1 by N2. 3 by 3. 1. So what is this? Rational number. Hence the signal is said to be periodic. Then what is the period? That is T. LCM of, so as this is continuous, it will be capital N. LCM of N1 comma N2. LCM of, what is N1? 3 and what is N2? 3. LCM of 3 comma 3 is 3. Okay, so the period of the given signal is 3 samples. Okay, these are different problems on periodic and aperiodic signals.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.